So in this video, we are going to show some examples of quadratic equations that we're going to solve using the quadratic formula. You're going to notice that in these examples, our two quadratic equations that we're going to solve do not start out in standard form. So our first example says 3x squared equals 2x plus 3. So we have to put our quadratic equation in standard form before we can substitute a, b, and c into the quadratic formula. So that basically means that you need a 0 on one side. And a good tip for you is try to keep your a positive, because that a is going to go under in the denominator of the quadratic formula, right, times 2. And we try not to have negative denominators. So do what you can to keep that a positive. So in this case, that means that we're going to leave the 3x squared where it is, and then we're going to subtract the 2x and the 3 to come join the 3x squared. So we'll get 3x squared minus 2x minus 3 equals 0. So now our a is 3, our b, which is the coefficient of x, is negative 2, and our c, which is our constant, is negative 3. And we're going to substitute right into the quadratic formula. Matter of fact, I'm going to come up here and we'll put it right under the formula. Okay, so opposite of b, and b is negative, isn't it? B is a negative 2. So the opposite of b will be a positive 2, plus or minus big square root. And now we're going to have b squared. So negative 2 squared is, right, b squared here, negative 2 squared is 4. So 4 minus 4 times a times c. So a times c is negative 9. And then all over, so you're going to put a big division bar, 2 times a, and 2 times a is 6. Okay. Now, we're going to simplify the radicand next. So that means we're going to do this multiplication right here, the negative 4 times the negative 9 next. And so that's going to give us a 36. So we put a positive 4 plus 36 under the square root. That's our radicand, all over 6. And then go ahead and add together the 4 and the 36. So we get 2 plus or minus square root of 40 all over 6. Now we're going to look at the square root of 40, and we're going to look for perfect squares. So 4 is a perfect square. So 40 is 4 times 10. And so square root of 4 is 2. And then the square root of 10 is left over. So 2 times root 10 all over 6. Now we're going to try to reduce this fraction, and we're going to look for reducing factors, not terms. So that means that we're going to look at the numerator, and we are going to factor out a greatest common factor, which is 2. So we're going to factor out a 2. Now, that leaves, notice that I'm factoring out a 2 or dividing out a 2 from a 2, this first term. That leaves a 1. Plus or minus, and then here, I'm factoring out the 2 from the 2 root 10, so that leaves a square root of 10. And then this is all over the 6. And now we're going to reduce these factors here. So 2 goes into itself once and into 6 3 times. So we have ended up with our 2 roots are 1 plus square root of 10 all over 3. Make sure you put that big division bar. And also 1 minus square root of 10 all over 3. These are the exact solutions. What kind of roots are they? Well, because you have that square root of 10, these are irrational. So you have 2 irrational solutions to this quadratic equation once again. Okay. And if your homework is asking you for a decimal approximation, then you're going to enter your solutions into your calculator to get the decimal, okay? But these two, the way they're written right now, those are the exact solutions. Okay, let's go to the next problem. So once again, we have a quadratic equation here that is not in standard form. So we are going to get 0 on the right-hand side because our a, our 4, here is positive on the left. So we're going to write 4x squared minus 16x plus 10 equals 0. Okay? A is 4. B is negative 16. C is 10. So x equals, the opposite of b will be a positive 16 plus or minus big square root 16 squared, which is 256, minus 4 times AC. A times C is 40. 4 times 10, 40. All over 2 times A. 2 times A is 8, 4, so this is an 8. And then we're going to multiply under the radical. So 16 plus or minus square root of 256 minus 160 all over 8. Then we're going to subtract. We're going to subtract 256 minus 160, which is 96. Okay. And now we're going to look for perfect squares in 96. So 96 is 3 times 32 for sure, right? And then 32 is 2 times 16. So here is our perfect square, the 16. So we have 16 plus or minus, square root of 16 is 4. Times the square root of, and then remember we have left over the 3 times 2, which is 6 under the radical. All over 8. And now we are going to look for factors at GCF. Greatest common factor in the numerator. We are not going to reduce terms. We're going to reduce factors. So 4 factors out, right? It's the greatest common factor. So 4 times 4 is 16. Plus or minus square root of 6 all over 8. And then we're going to reduce the 4. Goes into itself once and into the 8 twice. So we get these two roots, 4 plus square root of 6 over 2. 4 minus square root of 6 over 2, which are, what kind of roots? They're irrational roots, right? So now I want to show you a second way you could have done that last problem. And some of you may have noticed when you went to rewrite the quadratic equation in standard form that all of these coefficients, the 4, the 16, the negative 16, and the 10, that they were all divisible by 2. So because this is an equation, because we started out with an equation, we are allowed to divide by the 2, which is the GCF, first. So if you notice that, if you're solving your equations and you notice that there is a GCF, you're allowed to divide by the 2, in this case, first. And what that will do is that it will make the coefficients or the numbers that you're going to substitute into the quadratic formula smaller. So that might be easier to deal with. So we have now 2x squared minus 8x plus 5 equals 0. So now a is 2, b is negative 8, c is 5. X equals the opposite of b, which is positive 8, plus or minus the square root of b squared is 64, minus 4 times 8 times c, 2 times 5 is 10. All over 2a, which is 4. And so we get 8 plus or minus square root of 64 minus 40, 24. Right, that's our radicand. And over 4. And then square root of 24, well, this is 4 times 6. Square root of 4 is 2, so 2 root 6. So 8 plus or minus 2 square root of 6 all over 4. Then we're going to look at the numerator for a GCF of 2. This is a 4. And then we're going to reduce these two numbers, the 2 and the 4, by 1 and 2. So our final answers are 4 plus root 6 over 2 is one solution, and 4 minus square root of 6 over 2 is another solution. And we are once again getting irrational roots. And I want you to start thinking what's making the roots be irrational or rational or complex, because that's a future video.